Hello, this time we're going to come up with an example of the image and inverse image of a function on some particular sets. And the example that I choose is the function that is the length of a binary string on the symbols 0 and 1. So here, what I'm providing is just some evaluations of this function. If you evaluate the function on the string 0, 0, 1, well, we see that it has 3 characters, um, 3 positions, and so the length of the string is 3. If you evaluate it on the string 1, 1, 0, 0, well, we see that its length is 4, and just make this association. This one is just a special symbol to indicate the empty string. Well, which is the only string of length 0. Now, time for the examples of image and inverse image. So for the image, I choose this collection, which is a subset of X. It contains 4 strings: the string 0, the string 1, 1, 0, the string 1, 1, 1, and the string 1. Okay, so by definition, right, what is the image? The image would be the collection of all those natural numbers, members of the codomain, such that there is X in A with the property that y is equal to f of x. Okay, but how would we compute this? Well, by simply applying, if you want to do it this way, apply f to each of the members of A. So you want to signify it, that would be f of 0, comma, f of 1, 1, 0, f of 1, 1, 1, and f of 1. But this being the length of those strings, it would be 1, 3, 3, 1. Of course, this may be simplified to 1, 3. As a set does not, doesn't really care about how many times you mention the presence of an element in a list. Okay, well, that's it. That simplifies the computation of the image of A under F. Now, what about the pre-image? Well, for this one, I'll take this example, which is the one that was just computed from here. What is the pre-image of that? Well, let's see. By definition, this is the collection of all those elements of the set X, which is the domain, namely the set of binary strings on 0, 1, such that f of x belongs to 1, 3, the set containing 1, 3. But how do we interpret this? Well, this is the binary strings of length 1 or 3. Well, which ones are those? We can list them all. We have 0, we have 1, we have 0, 0, 0, we have 0, 0, 1, also 0, 1, 0, also 0, 1, 1, also 1, 0, 0, also 1, 0, 1, also 1, 1, 0, and also 1, 1, 1. If we count them, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. As expected, right? There are 8 strings of length 3, and there are 2 strings of length 1. Something that we can see here is, well, the operations of taking images and pre-images may not commute. So just be careful on that part. Now, in some places you may see that you take the inverse image of only one element, but this is just shorthand for f inverse image of the set 2. Now, If you know that the function is invertible, meaning that it's bijective, well, then it makes sense for this symbol to be considered as a function, because, well, there's only one item that is reversible, that is in the inverse relation to the given one that is provided here. But in the context of images and inverse images, well, when we write something like this, we really mean just this. And by the way, I'll leave this as a question. What is this set? And well, I would say put it on the comments and enjoy.